Today we are solving radical equations, so equations that have radicals in them. And it says check for extraneous solutions, and many teachers would say check every single solution to see if it actually works in the original problem. But really, there's two scenarios that have the potential to create solutions that don't actually work. So to save us some time and effort, if we can really just focus on those two scenarios, we won't have to check every single solution. The two scenarios are, I'm going to zoom in here so it's easier to read. If at any time in the solving process you have an even radical with something under the radical, and the other side of the equation is a negative number, that is a red flag. That indicates that we may end up with an extraneous solution. The other situation is when you have more than one solution. If in the process of solving you end up with more than one solution, definitely check both of them because the likelihood that one of them doesn't work is high. All right, let's start solving. When you are solving radical equations, you have to get the thing that's under the radical by itself before you can get rid of the radical. So in this first one, we need to subtract 6 on both sides. Now we can get rid of the radical. At this stage, I always check my two scenarios. This is an odd index, so it does not matter. It will be fine. Our solutions should be fine. To get rid of a radical that has an index of 3, you raise both sides to the third. You raise both sides to the exponent that matches the index of the radical. On the left side, that creates just x. On the right side, we need to do 6 raised to the third, which is 216. We did not have either of our two scenarios occur in that problem, so the answer of 216 is fine. Now, is it a bad idea to just go ahead and check every solution? No, I mean, you definitely would be okay checking every single solution, but neither of these two scenarios up here existed in this problem, so there's no reason to suspect 216. Number 2, first thing we would do is divide by -2. So we have the square root of 6x equals +8. This is a square root. That means an index of 2. So it's an even index. But over on the right side is a positive number, so we are still okay. To undo a square root, you square both sides. And then we would finish solving. Divide both sides by 6. And we can round this. It's 10.6 repeated, so 10.67. Number 3, excuse me, we have to get the radical by itself. So our first step is going to be subtract 5. This is a square root. That's an even index. And it's equaling a negative number. So this is a red flag. And I'm even going to draw in a little red flag. Because we have an even index radical equaling a negative number, there's a very good chance that this solution is going to be extraneous. I am going to finish solving it though. To get rid of a square root, we square both sides. Another really common mistake. -3 squared is +9. If I type into my calculator -3 squared, my calculator says -9 because it doesn't know what you're intending. But think about what squaring something really means. Squaring something means multiplying it times itself. -3 times -3 is +9. Anytime you are raising a negative number to an exponent, put that negative number in parentheses. -3 in parentheses squared is +9. We then finish solving. x equals 4. Because of this red flag here, I am going to check my solution. And we're checking the solution back in the original problem. So I need to do the square root of 4 times 4 minus 7, add 5, and see if it gives me 2. In my calculator, I do square root, and it gives me a spot under the radical. 4 times 4 minus 7. I move outside of the radical, and then add 5. It tells me that it's 8. So I get 8. 8 does not equal 2. This doesn't work, so this is an extraneous solution, and our answer is no solution. I want to show you what this might look like on your calculator. So I'm actually going to change my mode here quick. On your calculator, when you type in square root, you get this little parentheses. You'd need to do 4 times 4 minus 7, close your parentheses, then add 5 to have it calculate that correctly. The stuff in the parentheses is the stuff that would be under the radical. All right, number 4. Number 4, we need to start by subtracting 7. Negative 2 times the 4th root of 2x equals negative 10. If you're thinking, uh-oh, red flag, not quite yet. The radical's not by itself yet. Next, we need to divide by negative 2. So the 4th root of 2x equals positive 5. Even index radical equaling a positive number, this is still okay. To undo a 4th root, you raise both sides to the 4th. 5 to the 4th is 625. Divide both sides by 2. X equals 312.5. And again, it's a crazy box. Neither of our scenarios happened. We didn't have an even index radical equaling a negative, and we did not have 2 solutions, so our solution of 312.5 is fine. Moving on to number 5. In number 5, the radical is by itself. There's nothing multiplied in front of it. There's nothing added or subtracted after it. The radical is by itself. So to undo the radical, we are going to square both sides. And I'm going to write this down below. That means we take the entire left side, x plus 2 squared, and the entire right side, square root of 2x plus 28, we square both of them. On the right side, the square gets rid of the radical, and we have 2x plus 28. On the left side, what does a square really mean? A square means you're multiplying something times itself. So this is x plus 2 times x plus 2. So this is very important. X plus 2 squared becomes x plus 2 times x plus 2. You can't just square both things. Math doesn't work that way. You have to do x plus 2 times itself. This means we need to double distribute or FOIL or whatever you call it. So when I multiply this out, I get x squared plus 2x plus 2x plus 4 anytime that you have x squared and x in the same equation, you need to get one side equal to 0 so that you can factor and solve. So I need to subtract 2x on both sides and subtract 28 on both sides. X squared plus 2x minus 24 equals 0. I'm looking for two numbers that multiply to give me negative 24. You always multiply to get that third term, the number that doesn't have an x. That same pair of numbers has to add up to the middle term, the number that has the plain x. 1 times 24 would not work. 2 times 12, 3 times 8, 4 times 6, 4 and 6 would work if it's negative 4 and positive 6. This means our factored form is x minus 4, x plus 6. And our solutions are positive 4 and negative 6. One of the things we talked about at the very beginning, if we end up with two solutions, the chances that at least one of those solutions being extraneous is high. So we need to check both solutions. And we are going to check both solutions in our original problem, x plus 2 equals the square root of 2x plus 28. So if I plug 4 in, 4 plus 2 on the left side, on the right side, the square root of 2 times 4 plus 28. 4 plus 2 is 6. And you don't even have to do the whole right side. Just do the 2 times 4 plus 28. 2 times 4 plus 28. I get 36. Does 6 equal the square root of 36? Yes, that is true. So x equals 4 is a good solution. Now let's check negative 6. Negative 6 plus 2 on the left. On the right, 2 times negative 6 plus 28. On the left, negative 6 plus 2 is negative 4. On the right, 2 times negative 6 plus 28 is 16. Does the square root of 16 equal negative 4? No, it's not supposed to. The square root of 16 should be positive 4, so this is not good. The solution is not good. So x equals 4 is the only actual solution to this problem. So just to reiterate, when you are solving these things, if you have an even radical of something equaling a negative number, you are going to want to check your solutions. If you end up with two solutions, you are going to want to check your solutions. That should be it for today.